composition functions. What this is saying is that we're going to take two functions and we're going to apply them to each other. So let me explain this to you right quick with some notation. Composition function says that I'm going to take f, and I'm going to use capital letters because that's what I used in the equations I gave, of g. And I'm going to say of x because I'm not going to give you a value of x. But I could, you know, I could give you a value of x and you give me an answer back. So basically, this of means that I'm going to take my f function. So what is my f function? This right here. And I'm going to rewrite it. And everywhere I see x, I'm going to plug the g function in. So let's write our f function. This says that we got f of g of x. So my f function is 2x minus 1. And I'm going to plug in my g function, which is the square root of x. This one came out pretty nice and easy because 2 times the square root of x is just the 2 square root of x. And then we're going to subtract 1. And that's it. I mean, there's nothing else to this one because in order to add or subtract, you have to have common terms. And we don't have a common term here. We have a square root here, and then we have a constant. So that would be it of that. The only thing is that we need to find a domain. Sometimes you're asked to state the domain of it, and if you are, you always got to compare it back to the original. You know, so the domain here, it has an even root, so we got to look for its restriction. So basically, since we only have x here, we'd say x is greater than or equal to 0, and we're pretty much done, right? Now we just need to state that domain. So that domain says that we're going to include 0, and we're going to go off to infinity, positive infinity, because it says x is greater than, and we know we're got an equal sign on our 0, so we put a bracket. So the domain for my original would be this, and then we have to compare it to our composition answer that we got, and it's going to be the same in this case because you notice we got the square root again in our end answer. If we have a fraction, remember we have to look at the denominator to make sure and see what causes it to go to 0, and then if it does go to 0, then that's its restrictions. So that's a way of looking for the domains. Also, we're going to switch this up a little bit. Let's take our g of f of x and let's solve for that. Okay, and let's backtrack just a second. The reason why I compared it to the g, because the g is what I plugged in. Whatever you plug in to this function will determine the original domain you need to look at. So I plugged in g, so I knew to look at the g domain, and then come and look at the f of g right here and determine what its domain is and compare them. Because sometimes you're going to get two sets. You're going to have a union of domains, and sometimes you're just going to have one. So now let's look at this g of x, g of f of x. So that means I'm going to take my g function, and everywhere I see x, I'm going to plug in my f of x. In this case, it's 2x minus 1. And that is it. I mean, there's nothing else we can do because we don't know the value of x here. So what I'm going to do now is state my domain. Well, I had to plug in the f, right? Because g went first. That means the f function was plugged in. So I need to look at the f function and see what its domain is. And it is a polynomial. So its domain is all real numbers, right? So there is no restrictions here. So let's compare it to what we got. Well, we got an even root, so that means I need to take what's inside the even root, set it greater than or equal to 0, and solve. And when I do that, I notice that I got to add the 1 to both sides. So now I have 2x. It's greater than or equal to 0 or 1, and now I divide by that 2. And now I have a different type of domain. I have x is greater than or equal to a half. And this is my g of f function, right? This is its domain of the g of f. And my f function had no restrictions, so this one would stand true. We wouldn't have to union nothing. So I would make a statement of my domain is a bracket on 2 because of the equal sign, comma, positive infinity because it said x was all numbers greater than a half. So this would be my domain. So let's do one more thing. Let's take those g of x, f of x. So I'm going to have to take g of f of x. And let's say I know the value of x. Let's say that I know the value, and let's call the value, let's give it a 4. So I'm going to take my square root, because that's what my g function is, plug in for x, my f function, and everywhere as I see x, I'm going to plug in the value that it is. So now I have 2 times 4, which is 8. 8 minus 1 is 7. So this doesn't factor out. We're actually done because this would be the exact answer. The only way we'd go further is if you were asked to round. So that would be my exact. Thank you.